I guess for our November 11th notes, we have angle theorems and isosceles triangle theorem. In the last video, I mentioned something about, talking about triangle sum theorem. That's the first thing we're going to talk about. We don't have there's a lot going on, but not a lot going on in this video, so I'm going to start right away and make sure you are pausing to work problems out on your own. Make sure you're pausing and rewinding, okay? Now, these first two problems, I will let you know we're going to need to write small, okay, because there's not a whole lot of room to write in here. Let's talk about triangle sum theorem. Your triangle angle sum theorem, also known as a triangle sum theorem, is letting you know that the sum of all your interior angles is 180 degrees. So we're looking at this magic number of 180 degrees, all three angles adding to equal 180 degrees. So let's take a look at our examples here. Number one, what we're looking at first is find angle 1. Well, what we need to see about angle 1 is right here we have a linear pair. We have two angles adjacent that form a line. So all this is the measure of angle 1. We need to see this linear pair. See how small I'm writing, okay? So that means all we need to do is take that 180 that the straight linear pair adds up to 180. We need to subtract that 57 degrees so that we can find out what the measure of angle 1 is. 180 minus 57. You should have paused and used your calculator. We're going to wind up with 123 degrees. Okay? So angle 1 now is 123 degrees. So now let's talk about finding the measure of angle 2. To find the measure of angle 2, what I need you guys to see here is now we already have a triangle here with two of the three angles. So you can do this algebraically. You can do it as simple as just adding to the two angles and subtracting it from 180. I'm going to show you the algebraic here. I'll show you the other way, the quicker way over on number 2. So here we're going to have the measure of angle 2 plus this 57 plus the third angle of 71, all equal to 180 degrees. So we're adding all three angles up to equal 180 degrees, just like it says up here in the example. Measure angle A plus B plus C equals 180. So we just go through, we combine our like terms, the measure angle 2 plus, we take that 57, that positive 57, and that positive 71. We add them together, and we're going to get 128. This all equal to that 180. So keep in mind, all we did was add the two angles together right now. The next step that we need to do is get everything away from the measure of angle 2, our unknown. So we're going to subtract that 128 from both sides. And we're going to find out that in the end, the measure of angle 2 is equal to 52 degrees. Okay, so we're just adding and then subtracting. And I'll go ahead and show you the other way, just adding the two together and subtracting on this next one. For angle 3, you can do this. If you have two of the angles, you can always do this. All right. Measure of angle 3 right here, we have the two angles. One is 123, one is 28. So all you really have to do is take that 123 plus the 28, add the two angles we have together, okay, and we're going to wind up with 151. Then you take that magic number 180. We have 180 for all three of them. Well, if two of them are taking up 151, we need to figure out how many degrees are left over. There's your words, your math words for subtraction. How many degrees are left over to give to angle 3? And here we're going to wind up with only 29 degrees left over for angle 3. So you have angle 2 and angle 3. Those are two different ways that you can do this process. Most students like to just do it the easier, or not to say easier way, but the quicker way of just adding the two angles and subtracting from 180. And that's what I will be doing. Okay? So let's go ahead and take a look at number 2. Let's find the measure of angle 1. So right here, we're going to use exactly what we just did for angle 3. We're going to add the two angles together, and then we're going to subtract from 180 to get the measure of angle 1. So here, the measure of angle 1, we're going to take 85 plus 40. We're going to find ourselves with 125 degrees for these two angles together. And then we need to find, okay, if we have a total of 180 for all three angles, two of the angles add to equal 125, what is left over for poor little angle 1 over here for its measurement? We're going to find out this will be 55 degrees. So that will be our end answer right there. Okay? To find the measure of angle 2, let's take a look. What we need to notice here is that right here what we have learned is we have vertical angles. Get used to seeing this. I'm telling you right now, you're going to see this and you're going to have to see it on your own. You're not going to be told, hey, look, angle 1 is congruent, I'm telling you now, but you're not going to later, is congruent to angle 2 because we have vertical angles. So what that means, therefore, the measure of angle 1 is equal to the measure of angle 2. So if the measure of angle 1 we found out was 55 degrees, that means the measure of angle 2 is also going to be 55 degrees. You're going to have to be able to see these two triangles connected where you have two lines crisscrossing and we have two angles here, vertical angles. They will be congruent. All right, measure of angle 3. Let's check out what happens with the measure of angle 3. Measure of angle 3, we're going to do exactly what we've done with the with number 1 earlier, the measure of angle 1. We know that angle 2 is 55 degrees. We know that we have another 55 over here. So we're going to take our 55 degrees for measure of angle 2 plus the other 55 degrees for the other angle they gave us. We're going to wind up with 110 degrees. Then we need to come up here and say, okay, we have 180 for all three. Two of these angles add up to 110, so what's left over for the measure of angle 3? We subtract that, and 180 minus 110 is going to give us 70 degrees. Okay? So it's all a matter of really adding and subtracting here and taking a look, and we're going to need to notice those vertical angles as well coming later on. Okay, so your triangle sum theorem or your triangle angle sum theorem or your angle sum theorem, all three angles of a triangle add to 180 degrees. Pause if you need to take that in. We're moving on to the next one. We have exterior angle theorem. Here we need to identify a few different things. We have our interior angles, which that word interior we should already know from parallel lines and transversals. This means inside. So we're looking at the angles on the inside, the interior. So you're looking at angles 1, 2, and 3 right here. They're interior because they're inside that triangle. Your exterior, as we know, means outside. Okay, these are going to be formed by one side of the triangle, an extension of an adjacent side. What that means, I know it sounds confusing, but you're going to take one side, let's say side BC right here, and you're going to take side AB. The extension means you're going to extend one of those sides and you're going to create this exterior angle right here. Okay, and you see where it says the word exterior. So angle 4 is your exterior. These are very, very important when finding that, when using your exterior angle theorem. Now, your remote interior angles, what we need to understand about these are the angles that are not adjacent or next to the exterior angles. So here it says angle 1 and 3 are remote interior angles. Look at angle 1 and 3. Look at where the exterior angle is. You see how angle 1 and angle 3, neither one of them touches angle 4. Remote, think about a remote control. Is it attached to your TV? No. Think about a remote control car. Is the remote you're using, even nowadays, your remotes for Xbox and PlayStation, are they attached to it? No, they're remote. They're away from. So angle 1 and 3 are not attached to your exterior angle. They are remote, not attached. So what your exterior angle theorem is saying is that the measure of this exterior angle, angle 4 over here, okay, is going to be equal to the sum of your remote interior. So you're going to take your two remote interior angles and add them together. Here you see that if you take angle A and angle B, the two angles that do not touch or detached from your exterior angle, you add them together and that's going to equal over here. What I always call this is, as long as you're adding the right inside, inside plus inside equals outside. but you have to make sure that you are using your remote interior angles, okay, the two that do not touch it. Let's go ahead and see what this looks like with just plain simple numbers. When I look at this, I see my inside, remote, not touching angle 1, plus my inside, not touching angle 1. This is the non-remote, okay? These two are remote. They are going to equal my exterior angle. So here all we have is, we have the 27 plus the 52 is going to equal the measurement of angle 1, your exterior angle. So your measurement of angle 1, when we add 27 plus 52, will be 79 degrees. Inside plus inside equals exterior outside. Remember, your remote inside added together. So let's take a look at another example here where we're actually missing one of our interior angles. Again, you're looking at inside versus inside. Inside plus inside is going to equal that exterior. Here we see our right angle, so we know that we're going to have measurement of angle 4 up here. Okay, so the measurement of angle 4 plus the other remote interior, which we see as a right angle, 90 degrees, right triangle from the previous unit, our previous notes, plus 90 is going to equal the exterior, 123. So all we need to do is subtract that 90 from both sides, and we find out that the measurement of angle 4 will give us 33 degrees. And a problem like this, you really don't need to set it up algebraic either. You can just say, okay, well, I know I need to subtract, I need to subtract the interior angle from the exterior angle. I can get that other remote interior angle. But this is it algebraically. Speaking of algebraically, this one we're going to have to do algebraically. We're going to have inside plus inside is going to equal that outside right here. So we have that. I'm going to put the x first. I have x plus my other remote interior, 50, all equal to the exterior angle, 2x minus 15. So again, I'm going to go through this quickly, pause it, solve for x on your own, okay, and then resume and make sure that you got x correctly. I'm going to subtract that x from both sides. I'm left with 50 equals 2 x's. I take 1 away. I only have 1 x left. Bring down that minus 15. Add 15 to both sides to get rid of anything next to x. X is going to equal 65. Now this did want the measure of the exterior angle. So what we need to do now is we need to go up here and we need to find, okay, the measure of the exterior angle was 2x minus 15. We are going to remove x and plug in or substitute in what x was. That's 65. When we do 2 times 65, we will get 130 minus 15. And that will give us 115 degrees as our exterior angle. All right? Pause, soak that in, rewind if you need to. We have one last thing to talk about. We have our Isosceles Triangle theorem. Your Isosceles Triangle theorem is something that's kind of mentioned a little bit on the last things. The first thing we need to do is we need to make sure we understand the parts of an isosceles triangle. This is extremely important because when we start talking about things, we need to know exactly what we're talking about. When we start mentioning legs and vertex angle, base angles, you need to know what we're talking about. Your legs are going to be the two congruent sides. So right here, you have your two congruent sides that are going to be your legs. Right here. Your vertex angle is the angle formed by your two legs. So right here it says angle 1 is the vertex angle. Your base angles are going to be the two angles formed at the base of the triangle. I don't want you thinking base at bottom. What I want you to think of is opposite of the legs. So your base angles are going to be where you have your two congruent legs. They're going to be the two angles that are opposite. And we need to understand that sides and angles are opposite of each other in triangles. This comes up a lot in this unit. So here it tells us that angle 2 and angle 3 are base angles because they are across, they're the two angles across from the legs or the two congruent sides. Your Isosceles Triangle theorem is going to state that there's two ways you can look at it. If you have two congruent sides, then the two angles opposite are congruent. Okay? Hold in there. Your two congruent sides, you go to the angles on the opposite, we just talked about right here, your base angles are going to be congruent. Same thing if I give you that two angles are congruent. Let's say that we have two congruent angles. Then the sides opposite will be congruent. So you can go either way. I know it sounds confusing. Let's look at what we have here. Over here, we're told that segment AC is congruent to segment BC, and we can see that right here with our congruent markings. What that means is here you have your biconditional if and only if. You go across to the opposite of those sides, and you're going to get angles. Those two angles will be congruent as well. All right, same thing the other way. If I told you that angle 1 and 2 are congruent, you go across and tell me that segment AB and BC are congruent. Let's look at some examples here in a moment. Let's first go back and say, okay, how do we name these? All right. First, we're going to classify this triangle by its sides. Okay, easy enough. I see two congruent marks. That means we have an isosceles. Plus, we're kind of talking about isosceles triangle, right? Classifying by its angles. Well, they don't have any measurements. I'm going to go ahead and let you know that this is going to be an acute isosceles triangle. We're going to name these different things that we talked about, the legs, the vertex angle, the base angle, okay? The base even. Here we have our legs are going to be the two congruent sides, so right here, segment AB and segment AC. Those are our legs because they are the congruent sides. Your base angles are going to be the angles that are across from your congruent sides or legs. So this will be angle B and angle C, and they're not always on the bottom. Your base is going to be what connects those two base angles. Okay? So segment BC. Makes sense, right? The base connects the base angles. Okay? Remember also that your base angles are always congruent on an isosceles triangle. Last, we want our vertex angle. The vertex angle is the angle that's not congruent. So that one last angle that's all by its lonesome, has nobody to be congruent with, that's going to be your vertex angle. And that comes up in problems. It'll say your vertex angle is this. You need to know which angle we're talking about. Last two problems for the notes. Again, please stop and rewind. I know I'm going fast, but I don't want to make a 30-minute video. Here we're going to find the measure of angle P. We're going to have to write kind of small here. So first things first, we're going to find this angle right here, so we're going to have to plug back into 8y minus 16. What we need to see here is we have two congruent sides, and what we learned is that the angles across from these two congruent sides right here will be congruent. And we've learned when two things are congruent, their measurements are equal. So all we're going to do is we're going to set these two equal to each other. So we'll have 6y equals 8y minus 16. Okay, again, I'm going to go fast, so make sure you pause and you know what's going on here. I like this algebra problem because now you see what happens if we move the smaller variable and nothing's left. What I mean by that is I'm going to move my variable to the smaller coefficient, that's 6y, subtract it from both sides. Well, what's left on the left? Absolutely nothing. And the number for nothing is 0. No big deal. We're going to replace it in a minute, okay? This is okay. It happens. 8y's, I take 6 away. I have 2y's left. Bring down that minus 16. This is now where we're going to take the constant and move it to the other side. So we're going to add 16 to both sides, and it takes care of that 0 on the left. So we have 2y on the right. We have 0 plus 16. We have 16 on the left. So no more 0 involved. Last step, divide both sides by the coefficient. We're going to come up with y equals 8. Now they wanted the measurement of angle P. So we're going to go ahead and bring this up and say, okay, the measurement of angle P was 8y minus 16. We're going to, just like we've always done when we substitute or plug it in to find a measurement, we're going to remove that y and replace. Well, we found y was 8, so let's remove the y and put 8 in there. 8 times 8 gives me 64 minus 16. Giving us the final answer, the measurement of angle P will be equal to 64 minus 16. You should be pausing and working this out. Is equal to 48 degrees. All right. So I gave you hey guys, you have two congruent sides. You need to know the angles across are congruent. Now let's take a look at when I give you two congruent angles. So just the opposite. Okay, you have two congruent sides. The opposite angles are congruent. Here we have two congruent angles. So the sides across are going to be congruent. That's how you know which of these three to use. We saw a problem like that before on the first set of notes, and I told you guys that you have to know what's congruent here. So in this case, we are going to be looking for the length of AB, so we are going to have to substitute in. So this one is not extra information on here. So we take the two that are congruent, or two congruent sides. We know they're congruent because they're across from the congruent angles, and we set them equal. They are congruent. Their measurements are equal. 2x minus 4 is equal to x plus 5. And we go ahead and solve for our x. Variables on one side, constants on the other. Let's move that x over. We're left with x minus 4 equals 5. I moved my variable in this problem to the left, so my constant, the 4, needs to go to the right. So we add that 4, opposite operation. X is going to equal 9. Now we find AB, what they wanted us to find here. We knew that AB, as we can see, is 2x plus 2. Just like we've been doing, we're going to remove x. All I've done was removed x, and I'm going to substitute in what x was, which was 9. 2 times 9 gives me 18 plus 2. We find out that the length of AB is going to be 20. All right, a lot in here. Slow down, rewind, ask your teacher questions when you return to school, please.